Phylogenetics is the study of relationships that exist among and between species or individuals. This is done by reconstructing phylogenetic trees, which serve as graphical representations of the level of similarity that exists between operational taxonomic units, or OTUs. The most similar OTUs have the fewest amount of differences between their DNA sequences. In today's phylogenetic assessment, we will be constructing a tree comparing the divergences that have occurred in kitchen utensils. Rather than comparing DNA sequences, we will make comparisons based upon the phenotypes of the utensils. The tree created here traces the evolution of kitchen utensils used for the purpose of holding food. Kitchen utensils have come a long way from just a knife and fork. Here we have the items that I have selected to include in my tree. They are all individual species that have evolved from a common ancestor. We will refer to them as OTUs. To make this tree, I grouped together items that are similar in appearance and serve a similar purpose. All of these items are capable of picking up solid food, but some are also capable of picking up and holding foods in liquid form since they do not have slits penetrating through them. This added feature is an advancement from the common ancestor, the fork. When we group the items together based upon that division, we get two groups. One group here with the cooking spoon, the ladle, and the cake spatula, and the remaining items are above here in the next group. The fork here is the outgroup, since it is the OTU known to have diverged earlier than all of the other OTUs. It will serve as the root to our tree, allowing all the other OTUs to share a common ancestor. With rooted trees, the distance between the OTUs is known and the order of divergence is determined by comparing the OTUs to the outgroup, or the fork in this case. I chose to do a rooted tree rather than an unrooted one because the order of divergence can't be determined with an unrooted tree. When looking at this tree, we have multiple branch points shown here. One branch point is called an internal node. It represents a common ancestor prior to divergence. Divergence is a result of cladogenesis. This is the splitting of one lineage into two, allowing the branches to evolve separately, resulting in diversity of kitchen utensils in this case. Anagenesis, on the other hand, is the evolution within a lineage over time. An example would be the progression of the spatula, changing from plastic to metal over time in order to handle heat more appropriately. The most recent common ancestor is represented by the closest node between two species. An example of this would be this node specified here, and that would represent the most recent common ancestor between the spaghetti fork and the slotted spoon. It is also important to point out that the length of the line indicates how closely related the species are.